Hello everyone, welcome back to the channel. Today we are diving into another essential topic for our Easa Part 66 exams, physics. Whether you are preparing for the category A, B1 or B2, this video will break down the concept you must understand in simple and practical way. So grab your notes, stay focused, and let's make Part 66 physics easier than ever. Let's get started. So apparently the Part 66 Module 2 exams, which is the physics, is broken down into 5 sub-modules. We have the matter, we have the mechanics, thermodynamics, optics, wave motion, and sound. But today we're going to solve the questions that falls under the category of mechanics. So when you pick mechanics, we have 4 sub-modules. We have the statics, kinetics, dynamics, and fluid mechanics. Just to add to it, the Part 66 Module 2 physics, there are 56 questions in total. Your required time is 65 minutes or 1 hour 5 minutes. But remember, no calculators are allowed. So apparently you have to use estimations. When you're doing your calculations, make sure your numbers are within the limit, or when you add or divide whatever function you're using, try as much as possible to estimate it closer to the number, because since you are not using calculators, majority of the time you are not going to get the exact number or the exact answer that they are requiring. Alright, let's begin. I would like to start by stating the step-by-step method to solve physics problems. First of all, you have to read the problem carefully. Identify what is given. Identify what is being asked for. If possible, draw free body diagrams for force problems, motion path for kinetics or kinematics. If you have circuit diagrams, you can draw it as well. So these free body diagrams enable you to picture what the question is trying to say. So when you identify what is given, identify what is being asked for, list the parameters. This will help you to determine the kind of formula they require for you to solve the problem. So let's get straight into it. Question number 1 says, if the net force applied to a body is 112 newtons and the mass of the body is 28 kilograms, what is the acceleration? So you have the force equals 112 newtons, the mass equals 28 kilograms. So after you've listed what is being given, you could figure out that they need a formula for force, which is mass times acceleration. Force equals mass times acceleration. Force is 112 newtons. Mass is 28 kilograms. Acceleration wasn't given. The question requires you to look for acceleration or find acceleration. So times A. Making A the subject, 112 newtons divided by 28 kilogram. The answer is going to be 4 meters per second squared. Take note of the units. It's asking for acceleration, so it's meters per second squared. It's not meters per second. Meters per second is velocity. So that is the right answer. Let's get straight into number 2. 1 radian is equal to, with this type of question, sometimes it gives you the value of the radian. 1 radian equals approximately 57 degrees, but there is no 57 degrees there. It gives you the definition for a radian, which is the angle subtended at the center of the circle when the arc length formed between 2 radial lines is equal in length to the radius. That is the right answer. Number 3, A car moves over a distance of 5 miles at a steady speed in 10 minutes. What is the speed? So it gave you the distance. The distance equals 5 miles. Time t equals 10 minutes. But the answer is given in mile per hour, so you have to convert the 10 minutes into hours, which equals 10 divided by 60. That will give you an hour. So speed equals distance over time. Speed equals 5 divided by 10 over 60. That is going to give you 5 times 60 over 10 equals 300 over 10. That is 30 miles per hour. That is the right answer. Number 4, if you drop a stone from the top of a cliff and it falls freely, neglecting air resistance, the acceleration of the stone as it falls, because neglecting air resistance is imperative in this question, acceleration of the stone remains constant. 5, velocity ratio, VR. Straight away, the velocity ratio is distance moved by the effort over distance moved by load. That's the formula for velocity ratio. So distance moved by the effort divided by distance moved by load. That is the answer. Number 6. In periodic motion, the periodic time t of a swinging pendulum is the time taken to travel one complete to and fro. If you have a pendulum, this is a free body diagram. When the pendulum swings to the maximum point and back there, that is a period t. Seven, a forklift raises a load vertically at a velocity of 0.3 meters per second whilst traveling forward at 0.4 meters per second. What is the resultant velocity of the crate? So this question is all about vectors. So these are perpendicular vectors. These vectors are perpendicular to each other, which means they have 90 degrees in between them. So drawing a free body diagram, you have a straight line not drawn to scale. Okay. There you have 90 degrees. Yeah. So 0.3, 0.4, because they have the same decimal point, you can choose to represent it by 3 and 4 in order for you to find hypotenuse. So we're going to use Pythagoras theorem here. Forward is 0.3, sorry, 0.4, vertically 0.3. So we're going to represent 3 here and 4 there. I represent the hypotenuse by x. So x squared equals 3 squared plus 4 squared. X squared equals 9 plus 16. X squared equals 25. X equals the root of 25, which equals 5. But because we reduce our decimals, into whole numbers, we have to revert it back into decimals. That's going to give us 0.5 meters per second. That is the right answer. You can also try to use the Pythagoras triples. So we have, if you know this by heart, we have 3, 4, and 5. We have 6, 8, and 10. 12, 16, and 20. You could see that it follows some pattern. So 3, 4, 5, 6, 8, 10, 12, 16, 20. If you go down, it's in multiples of 2. Number 8. Which of the Newton's law apply most directly to a car which is slowing down due to the braking force? The braking force means retardation. In Newton's laws, we have the first, second, and the third law, and it's only the second law that applies to this. Force equals mass times acceleration. That was the second law. So that's the right answer. Number 9, acceleration. Acceleration A equals change in velocity over time. That is final velocity minus initial velocity, all divided by time. So final velocity minus initial velocity divided by time. This is the right answer. You can pause and try and solve these questions yourself before I give you the answer. Number 10. If a mass at the end of a spring is released and allowed to oscillate, it extends down, reaching 10 centimeters above the ground at the bottom and 24 centimeters above the ground when it rebounds back. What is the amplitude of the oscillation? So you can't draw a free body diagram to represent or to see clearly what the question is trying to say. So we have this pendulum hanging, and that is the string. Okay, so it extends now, reaching 10 meters from the ground. Sorry, 10 centimeters. So this is the flow. That is 10 centimeters. It rebounds back at 24 centimeters above the ground. So let's say it reaches here, 24 centimeters. So we are going to consider the distance traveled, or the rebound distance, and divide it by 2. That will give you the amplitude of the oscillation. So 24 minus 10 divided by 2. That is 14 divided by 2, which is equal to 7 centimeters. Question number 11 says, which of the following affect the velocity of an object? So velocity is a scalar, sorry, it's a vector quantity. So velocity is a vector. It's a vector quantity. So it has magnitude and direction. So it's affected by the speed and direction. That is the right answer. So we have the magnitude and direction. 12. An aircraft travels at 500 kilometers per hour for 30 minutes at a steady speed. How far does it move in that time? So it's giving you the speed, 500 kilometers per hour, time 30 minutes. You have to convert it to hour. That's going to be 30 divided by 60. And the question is looking for distance. Since we know speed equals distance over time, distance equals speed times time. So distance, we are going to get 500 kilometers per hour times 30 over 60. You can reduce this to 1 over 2, which equals 500 times 1 over 2. That is going to give you 250 kilometers. That is the right answer. This on the runway, what is acceleration? So first of all, we have to list the parameters what the question has given us. Then secondly, we try to figure out which formula we are going to use. You might probably use Newton's law of motions or Newton's formulas. So let's go straight into it. It gave you a mass M of 300 ton. It accelerates from rest, so initial velocity equals 0 meters per second. The final velocity equals 80 meters per second, and it covers a distance s of 2 kilometers. Since there is no time in the parameters, you are not going to use a formula involving time, and the only formula without the time is v squared. So we have v squared equals u squared plus 2as. The question is looking for acceleration, so we make acceleration the subject. A equals v squared minus u squared divided by 2s. That is going to give you v squared is 80 squared divided by 2 into 2 kilometers, which is 2,000 meters. That's going to give you 6,400 all over 4,000. These two will go. That is going to give you 64 divided by 40. 4 goes here, 16, here 10. So the answer is going to give you 1.6 meters per second squared. Well, that is the answer. Alright, straight into our question 14. An object moves in a radius of 5 meters at an angular velocity of 5 radians per second. Its linear velocity will be, it's trying to talk about angular velocity in relation to linear velocity. So the formula we're going to use equals linear velocity equals angular velocity times the radius. V equals 5 rads per second times the radius is 5 meters. V equals 25 meters per second. That is the right answer. Question number 15. Acceleration involves change of position over time, steady speed over time, steady speed over a fixed period of time, change in speed or direction of movement. Acceleration is basically the change in speed or direction of movement. That is the right answer. The flywheel is rotating at 60 RPM. its angular velocity is. So you have to convert RPM to radians per second. So 60 RPM divided by 60 times 2 pi. Because we are not using calculator, we have to approximate 2 pi equals 6. 2 pi equals 6. That's an approximation. So 60 divided by 60 times 6 is going to give you 6 rads per second. That is the answer. Alright, question number 17. An aircraft flying in a circle of radius 500 meters flies through an arc of 340 degrees. What distance will it cover? So it gives you the radius. As we always do, you list the parameters. Radius 500 meters. It gave you an angle. Theta equals 340 degrees. We have to convert it into radians per second. What distance S will it cover? So the formula, distance equals angle times radius. So the distance equals 340 degrees divided by 360 times 2 pi times 500. So we have converted it into radian per second straight away. So S equals, that's 34 divided by 36 times 6 times 500. So 2 pi is approximately 6. Because we are not using calculator, I state it again. We go straight into 2 pi, it's approximately 6. Right. So we are going to have 17 over 8. S equals over 18 times 6 times 500. 6 go here 3 times. That will give you 17 times 500 all over 3. Alright, so this is where it gets very tricky. We are going to assume that the 17 is 18. So 3 go here, 6. So you're going to get 6 times 500. That's going to give you 3,000 meters. So you go for that answer. Right, let's get to number 18. Which of the Newton's law relates to the formula force equals mass times acceleration? That is the Newton's second law. The advantage of using a machine is the mechanical advantage of the output force. So that is the right answer. Question number 20. An aircraft starting from rest, which means the initial velocity equals 0 meters per second, takes 2 seconds to reach a takeoff speed of 60 meters per second. This represents an acceleration of. You've been given the time, you've been given the final velocity, initial velocity, you need acceleration. So time equals 20 seconds. Initial velocity equals 0 meters per second. Final velocity equals 60 meters per second. Acceleration equals x. So you're going to use the formula v equals u plus at. V equals u plus at. We have v equals u plus at. If you make a the subject, you're going to get a equals v minus u over t, which equals 60 minus 0 over 20. That is 60 over 20. We're going to get 3 meters per second squared. Take note of the unit, that's meters per second squared. 21. What is the moment of inertia of a hollow flywheel with radius r and a mass m and speed mu? Moment of inertia is mr squared. Moment of inertia I cos mr squared. That is the formula. Right, let's go to question number 22. The period of a simple pendulum is independent of the mass. So that is the correct option. If you state the pendulum, the period of a pendulum's formula, that is 2 pi the root of L over G. It has no mass in it, so it's independent of the mass. Right, now let's tackle question number 23. An aircraft flies 1,350 nautical miles in 2 hours 15 minutes. What is the average speed? Since speed equals distance over time, you have been given the distance to be 1,350. Please take note of the units, nautical miles, divided by time. The time is supposed to be in hours, so we have 2.25 hours. So when you divide 1350 by 2.25, you're going to get 600 nautical miles per hour. But realistically, since we are not using calculators, you can approximate 2.25 to be 2. So when you divide 1350 by 2, you are going to get 675. And comparing the options given, obviously you have to go for this. That is the closest you can get, 600 nautical miles per hour. Let's jump straight into question number 24. It says if a force of 10-pound force produces an acceleration of 2.5 feet per second squared, on what mass is it acting? So force equals mass times acceleration. If you make mass the subject, it will get force over acceleration. The force has been given as 10 pound force divided by 2.5 feet per second squared. When you divide 10 by 2.5, you are going to get 4 slugs. For some of you who don't know about slugs, one slug is approximately 14.6 kilogram. But the question wasn't, the options given, you couldn't see any kilogram in it, so you go for slugs. Number 25, ignoring air resistance in a projectile launched at an angle to the horizontal. Ignoring air resistance in a projectile launched at an angle to the horizontal velocity is unchanged during the journey. This is the right answer. An object travels 18 kilometers in 1 minute 90 seconds. 30 seconds. What is the average speed? We are still on speed. Speed equals distance over time. You have been given the distance to be 18 kilometers. 18 kilometers. And the time is 90 seconds. But the answer given is in meters per second. So you're going to convert the kilometers into meters. So that will give you 18,000 meters divided by 90 seconds. That will go there. 2 here. This is going to give you 200 meters per second. The resultant moment of a couple is called a torque. An oscillation is produced by a pendulum, which is length L. Mass of the pendulum is m and the gravity g. What is the periodic time t? Periodic time t equals 2 pi root of L over G. As I said earlier, you have to try as much as possible to get some of the formulas in memory, so you could just spot it right away when the question is given. Question number 29, it says convert the angular velocity 200 pi rads per second into rotational speed in revolution per minute. And whenever you are converting rads per second to revolution per minute, you multiply by 60 divided by 2 pi. So it's going to be rads per second times 60 divided by 2 pi. So we have 200 pi rads per second times 60 divided by 2 pi. Here you're going to get 200 pi times 60 divided by 6, since we are approximating 2 pi equals 6. Right, so 60 divided by 6 is going to give you 10. But you can rewrite 200 pi as 100 times 2 pi times 10. That is going to give you 100 times 6 times 10. This will give you 6,000 revolution per minute. That is the right answer. Feel free to pause the video and try to work out these questions for yourself before I dive into it. A weight on a spring is pulled down, stretching the spring until it is 10 centimeters from the floor. I think we've seen this question before. So we draw a free body diagram. That is the string. That is the weight. That is 10 centimeters from the floor. When the weight is released, it rises 24 centimeters above the floor. What is the amplitude? So when the weight is released, that is 24 centimeters above the floor. What is the amplitude? A. That is the distance traveled by the oscillation. So it's going to be 24 minus 10 divided by 2. That is 14 divided by 2 equals 7 centimeters. Into 31, if a captain applies a couple of 50 Newton meters to a control wheel of 0.8 meter wide, what is the magnitude of one of the forces? So you have been given the torque or the couple, that is 50 Newton meters. The distance equals 0.8 meter wide. You don't know the force, and torque equals force times distance. So therefore the force will be torque divided by the distance. This is going to give you 50 Newton meters divided by 0.8 meters. Alright, we don't have calculators to work these questions, so we have to do some approximations. So if you run up 0.8 meters to 1, that will be 50 Newton meters divided by 1 meter. That is going to give you 50 newtons. But do we have 50 newtons in our answers? No. So which one is the closest value? We are going to go for 62.5 Newton. If you divide 50 by 0.8, you are going to get 62.5 newtons. That is the closest value among all. Number 32, the size of a centripetal force of an object traveling in a circle increases with increasing mass of the object, decreases with decreasing speed of the object, increases with an increasing radius of the circle. If you know the centripetal force formula, centripetal force mv square over r. So this is the r. R is inversely proportional to the force. R is inversely proportional to the force. So increases with an increasing radius of the force, no. Decreases with an increasing speed, increases with an increasing mass of the object. That will be the correct answer. Increases with increasing mass of the object, because the mass is directly proportional to the centripetal force and inversely proportional to the radius. Centripetal force is directly proportional to the mass. Alright, question number 33. The force that acts on a body to cause it to rotate in a circular path is the centripetal force. That is the centripetal force. Question number 34. If a shaft is rotating at 2000 rpm, then its angular velocity is. When you are converting rpm into radians per second, you multiply by 2 pi divided by 60. So rpm times 2 pi divided by 60 is going to give you rads per second. So in this situation, we have 2000 on rpm times 2 pi divided by 60. And we know 2 pi is approximately 6. So we are going to get 2000 times 6 divided by 60. 6 divided by 60 is 1 over 10. So 2000 divided by 10 will give you 200 rods per second. This is the closest option you get, because when you divide it directly, you are going to get 209.5 radians per second. But because we did approximations, we get 200 rads per second. So you need to choose the option that is the closest possible value. Number 35, a body of mass 2 kg is released from a height of 5 meters in a vacuum. At what speed does it hit the ground? Take the value of g, or acceleration due to gravity, to be 10 meters per second squared. So we have the mass. We've been given the mass m equals 2 kg. We have the distance s equals 5 meters. Velocity wasn't given. Acceleration due to gravity 10 meters per second squared. So when you look at these parameters, we are going to use v squared equals u squared plus 2gs. U squared, u equals 0 meters per second because it was released from a height. So v squared equals u squared plus 2gs. V squared equals 0 squared plus 2 into 10 times 5. V squared equals 2 times 10 times 5 equals 100. V equals the square root of 100. That is going to give you 10 meters per second. Alright, so when you look at 36, it says a body starting from rest accelerates at the rate of 20 meters per second squared. What is the distance covered until the body reaches a velocity of 50 meters per second squared? So all the parameters has been given. We have acceleration 20 meters per second squared, velocity 50 meters per second. Because it starts from rest, you have 0 meters per second from rest, and the distance is not given. So looking at the parameters, v squared equals u squared plus 2as is what is going to use. You make s the subject, you have v squared minus u squared all over 2a. So 50 squared over 2 into 20. So 2,500 divided by 40 equals 250 divided by 4. And for 250 divided by 4 is going to give you 62.5 meters. By simple long division, you should be able to get the answer. When you look at 37, a car traveling at a speed of 5 meters per second. So that's the initial speed here. Accelerates at a rate of 1 meters per second squared. That's the acceleration. How long will it take to reach the speed of 20 meters per second? That's the final velocity. So you're looking for time. And whenever a question is given and it requires Newton's law of motion and time is mentioned, there are only two formulas, which is the v equals u plus at and s equals ut plus at squared over 2. But when you check the parameters, this is the most suitable formula to use. So v equals u plus at, you make t the subject, v minus u over a equals 20 minus 5 all over 1. That will give you 15 seconds. 38. An object in a circular motion at constant velocity. If the radius of the path is doubled, the centripetal force will. So first of all, before you solve this question, you have to state the formula for the centripetal force, which is F. Centripetal force equals mv squared over r. And what the question is saying, that if the radius is double, that is going to be mv squared over 2r. This is the same as half mv squared over r, which means the centripetal force is halved. So that is the right answer. 39. Newton's law of motion applies to all substance irrespective of the state. These are straightaway questions that sometimes you get in the physics exams. Velocity is defined as product of speed times time, rate of change of distance, rate of change of displacement. Velocity is the rate of change of displacement. Is displacement over time. Why is it not distance over time? Rate of change of distance. Speed is rate of change of distance. Velocity is a rate of change of displacement, because velocity is a vector quantity. So it's towards a specific direction. That's why we use displacement over time. 41. The SI unit of acceleration is there straight away, meter per second squared. 42. If a load of 50 newtons, so we're giving the load L 50 newtons, is moved by the effort E of 5 newtons. The mechanical advantage, which is equals load over effort, that's going to be 50 newtons divided by 5 newtons, which is 10 newtons. That is the answer. 43. An aircraft of mass 2 tons is traveling at a speed of 72 kilometers per hour. What is the velocity? These answers are given in meters per second. So basically what this question is saying is convert kilometers per hour to meters per second. And this is the formula. If you want to convert kilometer per hour to meters per second, you divide it by 3.6. So it's going to be 72 divided by 3.6. You can also rewrite it as 720 divided by 36 by multiplying the numerator and the denominator both by 10 to get rid of the decimal. So 720 divided by 36. So straight away you are going to get 20 meters per second. Meters per second. In a simple harmonic motion, the velocity reaches the maximum value through the resting position. What acceleration is produced if a mass increases speed from rest to 10 feet per second in 5 seconds? From rest, initial velocity is 0 meters per second. The final velocity v is 10 feet per second. And time equals 5 seconds. Acceleration is not given. So looking at the parameters, you can use v equals u plus at. V minus u divided by t is going to give you a, by making a the subject. V minus u is 10 minus 0 divided by 5. That is 10 divided by 5 equals 2 feet per second squared. That is acceleration. 46. What force is required to produce an acceleration of 5 meters per second squared of a mass 2 kilograms? So you have mass equals 2 kilograms, acceleration equals 5 meters per second squared. Force is not given, so force equals mass times acceleration. Force equals 2 kilogram times 5 meters per second squared. Force equals 10 newtons. A vehicle accelerates from rest to 84 meters per second in 3 seconds. Its acceleration is, from rest means initial velocity equals 0 meters per second. Final velocity v equals 84 meters per second. Time is 3 seconds. Acceleration is not given. Then again, v equals u plus at. A equals v minus u over t. A equals 84 minus 0 divided by 3. A equals 84 divided by 3. So when you divide 84 by 3, that's going to give you 28 meters per second squared. 28 meters per second squared. So that is the answer. Right, question number 48. A pendulum of mass 2 kilogram and 2 meters long swings with a period P. If its length is extended to 4 meters, the new period will be. So the formula for the period, let's put period as P equals 2 pi the root of L over G. The initial period P naught equals 2 pi over 2 over G, because the length was 2 meters and the length was increased or extended to 4 meters. So the new period, let's say Pn equals 2 pi the root of 4 over G. So this can also be written as 2 pi the root of 2 over G times root 2, because root 2 times root 2 is root 4. But as you can see, this one is the initial period times root 2. So this is going to give you P root 2. Alright, let's get straight into question number 49. A satellite requires 10 joules to rotate half a revolution, which takes 30 seconds. What is the energy required for 1 day? So half a revolution in 30 seconds is 10 joules. So you're going to write down the parameters and relate them. So we have, which means 20 joules equals 1 revolution in 60 seconds. If half of a revolution, 0.5 revolution equals 10 joules. That would means 1 rev equals 20 joules in 60 seconds. That was 30 seconds. So if 20 joules equals 30 seconds, what is the energy required for a day, which is 24 hours. So you have to convert 24 hours into seconds. That is going to give you 60 times 60 times 24. In the whole 24 hours, we have 86,400 seconds. 86,400 seconds. So therefore, if 20 joules equals 60 seconds, $86,400 seconds will be 86,400 divided by 60 times 20. 60 divided by 20 is 3. So we have 86,400 divided by 3. That is going to give you 28,800 joules. That is the correct answer. Oh, question number 50. An aircraft of 2 metric tons uses 800 kilojoules kinetic energy to make an emergency stop. It brakes apply a force of 10 kilonewtons. What distance does it travel before it comes to a stop? So you have the energy given. Equals 800 kilojoules. Force given as 10 kilonewtons. We're looking for the distance. So energy equals force times distance. Distance will be energy divided by force. That is going to give you 800 kilojoules divided by 10 kilonewtons, which is going to give you 80 meters. Alright, thanks for watching. Kindly subscribe to the channel and keep an eye on the part 2 of the questions under kinetics. You have a lot of questions to solve. Stay safe.